Exponential function 2. Graphs. So we're writing exponential function in terms of their graphs. We're going to sketch them. Y equals a to the power of x plus c. It's an exponential function where c is a constant. C is the line of asymptotes, and A, it's a number which must be greater than 1. So let's try a typical example. First of all, a line of asymptote is a line. So asymptote is the line that the curve approaches but never touches it. So that's what the line of asymptote is. In this case, C is always the line of asymptote. If C is 0, then 0 is the line of asymptote. Typical example is y equals 2 to the power of x. Well, y equals 2 to the power of x is actually, in this case, C is equal to 0. So the line of asymptote is y equals to 0. So when we're sketching that curve, you always need to show the point of y-interception. So in this case, let's make this 1, 2, 3. So this is y equals to 0. The x-axis is y equals to 0, and the y-axis is x equal to 0. So whenever you're sketching your curve, you always ask yourself, when x equal to 0, what is y? That would be 2 to the power of 0. So you replace x with 0, that's 2 to the power of 0, and that's 1. So this point here, x is 0, y is 1. So that's the 0, 1 coordinate. And so your curve will come in, approaches there, and then comes to approach the line of asymptote. But it will never touch it. So that's how you sketch it. So that's an exponential function. So let's try another example of exponential function where y equals e to the power of x plus 2. Remember that e to the power of 1 is 2.71828, and it goes on. So it's a constant number, and therefore we can use that number, but we just represent that number by e. So the line of asymptote in this case is 2, where you say y equals plus 2. So it's 2. If it's minus, it will be minus 2. So in that case, the graph of that will look like this. Again, a quick sketch. Now, the variable here, x, has a positive value because it's just e to the power of x. You could have e to the power minus x, which we'll look at later. Right, so in this case, the line of asymptote is 2. So you sketch your curve at point 2, and that's y equals 2. So this is 1, 2, 3, 4, 5. Now, we need to ask ourselves, when x equal to 0, y equals e to the power of 0 plus 2. Therefore, e to the power of 0 is 1 plus 2. That'll be 3. So y equals to 3 when x equals to 0. So this is a point 3. So the coordinate will be 0, x is 0, y is 3. So let me write that clearly. So that's the coordinate. And the curve, we come in exponentially. So let's just draw that. And approach the line y equals to 2, but never touch it. So that's the exponential function for e to the power of x, which is y, and x as your variable. Okay, let's try another curve. Y equals to 3 e to the power of x plus 1. Again, the line of asymptote is going to be y equals to 1 in that case. So y equals to 1 is the line of asymptote. And so when we're going to sketch our curve, we'll draw a line quickly. All right. And in this case, we then draw y. We draw a hidden line at y equals 1. So that's y equals 1. That's the line the curve will approach. Then we need to find when x equals to 0, y equals to what? We're trying to find the y-intercept. So that will be 3 e to the power of 0 plus 1. E to the power of 0 is 1, so that will be 3 times 1 plus 1. 3 times 1 equals 3 plus 1, and that becomes 4. So y equals to 4 when x equals to 0. So this is 1, 2, 3, 4. So this point is 4, so that's 2, 3, 4. And the point of interception on the y-axis, so the coordinate will be 0, 4. And the curve will obviously approach the line, but then never touch it. Let's just do it again. That's the exponential growth. And so you can see, in fact, I could draw it backwards. So this is where it's actually coming. And then it doesn't touch that line, y equals 1. So that's your y-axis, and that's your x-axis, minus x. Always label your axis. So that's the curve for y equals to 3 e to the power of x plus 1. So we've sketched all these graphs, few graphs, the positive power of the exponential function. There are 4 types of exponential basic graph that we need to know. 4 types. So I'm just going to put a line through here. So there are 4 types of exponential that we need to know. So we're using e. We could use a or any number. Actually, let's use a. So y equals to a to the power of x. They're all similar in terms of what they look like. So all the positive one, because the power is positive variable x. So the curve generally look like that. Let me just sketch that again quickly. And then you get when x is 0, y. So when x equal to 0 in this case, y equals 1. So that's the point there of interception. And because the constant here, the line of the constant here is 0, so the line of asymptote will be 0. So the curve will be coming there and then go that way. So that's what that looks like. So example would be y equals to 2x, y equals to 3x, y equals to 4x, and so on. So that's what they all look quite similar. Now, y equals to, the next graph we need to look at is y equals to a to minus x. This is the negative power of the x. So that graph is actually very similar to this one. So when x equal to 0, y still equals to a to the power minus 0, which is a to the power of 0, which is 1. Again, so it's cutting here at 1. You always put the coordinate 0, 1. And here it's also 0. Let me just put on this side 0, 1. In this time, this is a reflection along the y-axis. So the curve will be coming. Let's just draw it properly. Bad drawing. Okay, so it's going that way and approaches a line of asymptote, but never touches it. So it comes that way, it approaches the line of asymptote, which is in this case plus c, and c is 0. So let's say y equals to 0 here because it's plus c, but c is 0. And therefore it approaches that line, but never touches it. That's x-axis minus x-axis. The equation of the x-axis is y equals to 0. So the key function here, the important thing to note here is of the negative power here, and it's coming down like a decay function. So the next one to look at is the y equals to minus a to the power of x. This is now a reflection on the x-axis. It's very similar to the a to the power of x. And so the way we draw that is, again, it will be because when x equal to 0, y is going to be minus a to the power of 0, which is going to be minus 1. So it's going to be here. And therefore, so you're going to have 0 minus 1 as the interception, and therefore the curve will be going like that. So that's what the curve look like. That's y, that's x minus x. Again, y equals to 0 because the plus c here is 0. There's no value at c. C is 0, so therefore it approaches y equals to 0. You can guess what the curve will be for the negative of the power of the negative variable. Y equals minus a to the power minus x. In this case, it's a reflection on the x-axis. So you're going to get 0 and minus 1. And the curve will be when x is, let's say when x equals to 0, y is going to be minus a to minus 0 to the power minus 0, which is minus a to the power of 0, and that will be minus 1. So that's why it's minus 1 here. And now when we draw the curve, it's just going to approach 0 but never touch it, because y equals to 0 is a line of asymptote, because there's a constant here, c, and c is 0. So those are the 4 graphs that we need to know and understand in terms of exponential functions. Right, here's some examples of some of these graphs to sketch. Y equals to 2 to the power of x plus 1. Right, in order to do that, the first one, you can try it yourself and see if you can get it. And if you get it, then well done. And then check the answer out to see how you've done. So pause it, try it, and then see what you get. Right, y equals to 2 to the power of x on the left here, top left, plus 1. Well, 1 is a line of asymptote, so I will draw a broken line there. That's the line of asymptote. And then I will say to myself, when x equals to 0, what is y? Y will be 2 to the power of 0 plus 1. And that will give me 1 plus 1, and that's 2. So this is the point 2 there. And because it's a positive, I know if it's positive, it's actually going upward. So it's coming from left. Just draw it clearly. And approaching there and going up. Exponential. So that's how you draw that one. And the coordinate here will be 0. So that'll be 0, 2. That's the coordinate, the point of interception on the y-axis. So that's a y. So that's how you sketch that. Bottom left is, okay, so I'll focus on the power of the variable. In this case, it's negative. And so let's just draw the line of asymptote here, which is -1. So I come down here, it's -1 here. So I draw the line of asymptote. That's the line of asymptote. Y equals -1. That's the line of asymptote. So let me just write that clearly. Now, when the next thing to do is when x equals to 0, y will be -2 to the power of -0 minus 1. Well, 2 to the power of -0, so that'll be -2 to the power of 0 minus 1. 2 to the power of 0 is 1, so that'll be -1 minus 1, and that gives -2. So y is -2 when x equals to 0. So this is -1 here, and that's -2. That's the point of interception there. And this graph, because it's a negative, so it's a reflection on the, and also it's minus as well. So it's, first of all, it's a positive, well, if you look at it, it's a reflection of the positive and reflection of the y-axis and then reflection on the x-axis. So the graph is going to be approaching -2. Oh, sorry, -1, because the line of asymptote is -1. So we going to come this way and approaching -1. You might get that before I got it, so there we go. So the coordinates here are x is 0, y is -2. So that's the point of interception on the y-axis. So that's -y, that's y, that's x, that's -x. So that's how you sketch that. What about the top right? Okay, so we've got the line of asymptote here at -2, so there's -2, so draw the line of asymptote. So that's the line it approaches. Now, we also have to say when x equals to 0, y equals to -2 to the power of 0 minus 2, which gives 2 to the power of 0 is 1, so that's -1 minus 2, and that becomes -3. So -2 is there, and that's -3. So it's so this is approaching, crossing -3 and approaching -2. So it's actually coming this way. So that's the way that graph goes. Because it's approaching, cutting -3 and approaching -2. So that's the way that goes. Now, so that's the graph of y equals minus 2x to minus 2 there. And what about the fourth one? Let's try that one. So you got a line of asymptote plus 1. So we just draw that. It's approaching that plus 1. It's a decay because it's negative to the power of x, negative power of x. So when x is 0, y will be 2 to the power minus 0 plus 1, which will become 2 to the power minus 0 is 2 to the power of 0 plus 1, because 0 minus 0 times, well, 0 times minus 1 is 0. So then 2 to the power of 0 is 1 plus 1, that becomes 2. So that's 2. In that case, when y equals to 0, when x equals to 0, y equals to 2. So y equals to 2 when x equals to 0. So that's 0 here. That's 2 there. And the line it approaches. So this curve is coming from this side and approaching the line of y equals 1. So that's y equals 1 line. And that's the curve for that. And that's how you draw that exponential function of y equals to 2 to the power minus x plus 1. I have actually chosen the quite hard ones here. They look simple, yet they can be tricky.